Welcome everyone to IDEMI e-learning channel. In this module we are going to talk about basics of additive manufacturing. Purpose to understand how additive manufacturing works. Before starting this session, I would like to show you a picture which shows how far we have gone in this 3D world. This picture says everything. Building a 3D object. Subtractive manufacturing involves cutting away from a solid block of material. It could be a block of, for example, metal, plastic, or wood. Additive manufacturing is a process that adds successive layers of material to create an object. Formative methods are used for mass production of any component. Subtractive manufacturing by manually cutting the material is also possible. In fact, before the Industrial Revolution, that was how most of it was done. A milling machine cutting out a piece of metal or plastic is an example of subtractive manufacturing. In this process, a piece of solid material, typically called stock, is placed in the work area, and the machine removes material to create the object. The process involved are milling, turning, drilling, sawing, grinding, EDM, laser cutting, water jet cutting. In formative manufacturing, the machine injects liquid material into a mold and allows it to cool. For this is typical of high-volume production and requires an expensive mold to produce the products. Injection molding, casting, stamping and forging are all means of formative manufacturing. Additive manufacturing means creating three-dimensional objects by adding layer after layer. Since the turn of the century, additive manufacturing technology has advanced significantly. 3D printers today can even create jet engine turbines. In this process, the machine starts with an empty work area and, typically, extrudes or melts material onto it to create the object. Subtractive versus additive. Both additive and subtractive manufacturing have revolutionized the way products, parts and prototypes are made. Additive and subtractive manufacturing technologies are advancing rapidly. Rather than adding layers, subtractive manufacturing involves removing sections of a material by machining or cutting it away. It can be carried out manually or, more commonly, by a process known as computer numerical control, CNC, machining. Additive manufacturing is a process that adds successive layers of material to create an object, often referred to as 3D printing. The waste generated is less compared to subtractive manufacturing. Additive manufacturing, rather than producing an end result by taking material away, it adds to it instead. Traditional manufacturing methods involve a material being carved or shaped into the desired product by parts of it being removed in a variety of ways. Additive manufacturing is the pole opposite. Structures are made by the addition of thousands of minuscule layers which combine to create the product. The process involves the use of a computer and special CAD software which can relay messages to the printer so it prints in the desired shape. The pie chart shows leading national markets and market shares for 3D printing technology. US is leading at 39.59%, whereas India is at 1.6% for use of 3D printing technology. The pie chart shows users of additive manufacturing by sectors: motor vehicles with 17.3%, aerospace with 12.3%, industrial business with 18.5%, electronics with 18%, medical 13.7%, academic institutions with 6.4%, government 5.4%, architect with 3.8%. Suitable for use with a range of different materials. The cartridge is loaded with the relevant substance and this is printed into the shape, one wafer-thin layer at a time. These layers are repeatedly printed on top of each other, being fused together during the process until the shape is complete. Since the process is layer by layer, the actual output of the product can be like image 1 even if the input model is image 2. The steps involved in 3D printing are as follows. Creating the 3D CAD model of the design. Converting the CAD model into STL format. Slicing the STL file into thin layers. Constructing the model one layer atop another. CAD model creation. First, the object to be built modeled, using a CAD software package or by using a laser scanner or a coordinate measuring machine by reverse engineering technique. Conversion to STL format. The standard data interface between CAD software and the machine is the STL format, stereolithography. An STL file approximates the shape of a part using triangular facets. Small facets produce a high-quality surface. Since the .stl format is universal, this process is identical for all of the RP build techniques. STL format is then given to rapid prototyping machine software which does the further process. As shown on the screen, the rapid prototyping machine will trace the path and drop material to make a 3D model. What are the advantages of using additive manufacturing? Similar to standard 3D printing, additive manufacturing allows for the creation of bespoke parts with complex geometries and little wastage. Ideal for rapid prototyping, the digital process means that design alterations can be done quickly and efficiently during the manufacturing process. The lack of material wastage provides cost reduction for high-value parts, while has also been shown to reduce lead times. In addition, parts that previously required assembly from multiple pieces can be fabricated as a single object, which can provide improved strength and durability. Additive manufacturing can also be used to fabricate unique objects or replacement pieces where the original parts are no longer produced. Materials used for additive manufacturing is used to create a wide range of products across a growing number of industries. Is particularly suited to aerospace applications due to its weight-saving capability and ability to produce complex geometric parts such as blisks. A variety of materials are widely additive manufactured for the automotive industry as they can be rapidly prototyped while offering weight and cost reductions. The medical sector is finding an increasing number of applications for additively manufactured parts, especially for bespoke custom-fitted implants and devices. With this we end our video. Our next video we will discuss various types of process involved in 3D printing. Thank you.